Okay. Now what happens is this. There is a whole branch of math which is called numerical analysis, and I think we've done one portion of it. Yeah. But उस portion में we only did a technique how to solve equations which were not solvable by analytic methods. So we used the successive approximation method, the iterative method to solve any equation approximately, to get an approximate root of any equation, if you remember, right? Now, numerical analysis is it's a big branch of math. It just doesn't only deal with solving equations, it also deals with functions which want to be different, functions that we need to differentiate and functions that we need to integrate. Now, there are a lot of functions, by the way, for which we don't have any specific technique to integrate. After the P3 value integration that we did, I'm sure you all realize that every different kind of a function needs a different kind of technique for integrating. So you have to actually recognize कि fraction है, product है, trigonometric है, trigonometric power तो नहीं लगी हुई. You know, so every stuff has a different procedure, different approach, different technique to it. So those are all analytic methods. There are a lot of functions for which we don't have any specific method to integrate them. There is no analytical approach for it. So we come down then to a numerical approach. Now, numerical analysis में there are a few methods which are used to get the approximate answer for an integration process. So one of them is a trapezium rule. Simpson's rule भी है, पर आपने सिर्फ trapezium rule करना है. So trapezium rule, as the word says, trapezium. The idea is that integration of any function within the limits. Because हम integration करते क्यों? Basically to ultimately plug in values and get some answer out of it. So if let's suppose this is my target to integrate this function f of x within the limits a and b. So I'm unable to do it by any analytical method, so I'm going to use the trapezium rule, let's say. So the trapezium rule is going to allow me to get an approximate answer. If not the perfect answer, but an approximate one. Now, we all know that this graphically means the area of the curve, right? So, when I'm saying that I'm going to integrate f of x within the limits a and b, let's say this is a function, that's some function f of x. And if I'm saying that I want to integrate between a and b, so basically what I'm trying to say is that I'm trying to get the area under the curve from a to b. Let's say a and b are these x limits. So integrating that within a and b means I'm getting this area, right? Now trapezium rule ये कहते हैं कि भाई आपको area निकालना है, तो इस area को आप क्या करो, इसको break करो, break it into strips, and each strip then becomes a trapezium. So it says break it into strips. Let's say I'm going to break. I'm just explaining the situation, so I'm going to break it into some strips. So let's say I managed to break it into 1, 2, 3, 4, 5 strips. Each strip then becomes a trapezium. Each strip is a trapezium. Now, I think it is very reasonable to understand here that if I add up the areas of all these trapeziums, I'll get an approximate answer for the total area. Now, why the approximate? That is also very reasonable to understand, because इस process के अंदर कुछ जगह gaps रह जाएंगी और कुछ जगह unwanted area आ जाएगा. So sometimes you'll be like getting in more area than it is required, and sometimes you'll be letting off area which we should have taken in, but it's not coming inside the trapezium. So you'll be either getting an overestimated answer or an underestimated answer. So roughly, मगर आपको एक approximate answer मिल जाएगा. Now, if you want to improve on that answer, you take as many strips as you can. The more the number of trapeziums you take, the better answer you get. ठीक है? Okay. Now, so it comes down to basically adding up the areas of all these trapeziums. So first thing what we do is we find out this height of the trapezium. Do you notice this height? I've broken it down into equal intervals. Can you see? The intervals equivalent. So this is what we call h, the height of the trapezium, and this is found by taking b minus a upon n, where n is the number of trapeziums. You can say number of trapeziums, you can also say number of intervals, you can also say number of strips. These सारे words use हो सकते हैं. The question can say using 5 strips or 5 intervals or 5 trapeziums, it all means the same thing. ठीक है? So we have broken it down to 5 trapeziums. So b minus a upon n, b minus a gives you the range, divide by total number of trapeziums will give you the h interval of each width, basically the height of each trapezium, h. You all okay with that? अच्छा, जब ये h आ जाएगा, then the next thing what you need to do is you need to chalk out the x values. So the very first one you're starting off with is x naught. Let's say the very first one you start off with. The next one x1, उसके बाद x2, then x3. This is x4, and the last one in our case is x5. Okay. For this particular example. So x0 से लेके x5 तक. अच्छा, how do you find x0? Take x0, उसमें h add कर दो. You have the width h, right? Just add h to it. So basically, how do you get x1? It's x0 plus h. How do you get x2? It is x1 plus h. How do you get x3? It is x2 plus h. अब h add करके चले जाओ, and ultimately your final limit b पे आ जाएगा. Right? So your lower limit is x0. That's where you start off, and you end at your upper limit of the integration. अच्छा. Next, what you need to know is what are the y values. So I'm going to call this y0 and x0. I'm going to call this y1, this one as y2, and so on. So how do I find that out? Very easy. I put these x values here in the function. Your y is equal to f of x. Function already given होगा ना, आप like इसको integrate करो within the limits. I have the function. Put the x naught in it, get the y naught. Put x1 in it, get the y1 value. Put x2 in it, get y2 value, and so on. We're all good till here? Yeah. Achha. Next, my target would be to add up all the areas. So let me call this area 1, area 2, and so on. So area 1 is half into height into a plus b. That's the area of the trapezium. A plus b is the sum of the parallel sides. One parallel side is y0. The other parallel side is y1. Okay. Now this is a1. Next area a2, half same height, y1 plus, and then similarly I'll find a3, a4, and then a5. And so similarly I'll find a3, I'll find a4, I'll find a5. So the total area approximately would be a1 plus a2 plus a3 plus a4 plus a5. Now, the best part is this. You don't have to individually find all these areas. When I add up all these areas, पहले बात है half inch सब में common है, right? A1, A2, A3 सब में half inch common है. When you write all of them down like this, you can easily take the half inch common. तो पहले तो half inch common बाहर आ गया. ठीक है, उसके बाद अंदर क्या रह गया? y0 plus y1. अच्छा, now notice something. y0 and again it's y1 और फिर दोबारा next y1 a1 में आया. Now a2, a3 के अंदर you'll get another y2. a4 में you'll get another y3. So what will happen at the end is this. y0 और y5 को हटा के जो middle वाले सारे ना वो दो दफा आएंगे. So your formula will end up as y0 plus last one y5 plus 2 times y1 plus y2 plus y3 plus y4. This is how your formula will end up. all the intermediate ones will come twice. The first one and the last one will come only once. So this is the general form of your formula. This will always be the case. अब अगर मैंने seven strips दिए होते, then it would have been y0 plus y7 plus 2 times y1, y2, y3, y4, y5, y6. All the intermediate ones twice, first one, last one as it is, multiplied by half edge, you get it. This is the Trapezium Rule. Simple. So it's very reasonable to understand this, and we can do a question now. Are we all good? Yes. Can you move on? Yes. Let's try this. The questions are always like these. Okay, now see, this is, we need to find this area. Basically what he's asking you to do, in other words, he's asking you to do this. Integrate from 0 to 2, root of 1 plus x cubed. This is what he's asking you to do actually. Which he's saying in terms of area, basically this is what he's asking you to do. Now for this, we use a Trapezium rule. Let's say you can't, by the way, you can't integrate this with the techniques you have. This requires substitution. And let's say you substitution नहीं दिया हो, तो आप कैसे integrate करोगे? आप नहीं कर सकते. So let's use the Trapezium rule here. Now it says use the Trapezium rule for intervals. So he wants us to take NS 4. He wants us to break the area into 4 intervals. 1, 2, something like this, right? So equal है, उससे equally बड़ा बड़ी निकालो. Now this is your H. H is B minus A upon N. So your H is 1 by 2, 0.5, which means your x naught is 0, x1 is 0.5, x2 is 1, x3 is 1.5, and x4 is 2. Agreed? Yeah, after 0.5 in. This one is 1, this one is 1.5, and this is your x4. 2. Now, next thing what we need to find is the corresponding y values. So let's find y0, y1, y2, y3. Okay, let's take the exact values for the moment. ताकि वो फिर राउंड वगैरह नहीं आ जाए. तो 0 पे आ रहा है 1.
0 to over 4.
नहीं, root of 0.5 cube plus 1 क्या है? 0.5 cube plus 1.
9 over 8. 1.125.
1.125. Exact value, that's fine. So y2 क्या है?
Root 2.
y3 1.5 cube plus 1.
4.375.
4.375. Exact.
Yes.
y4. y4 is exact 3. This is what we're getting. Agreed? Now, clearly, area is half into height, which is 0.5 into y naught plus last one, okay, y naught plus y4 plus 2 times all the intermediate ones, plus 2 times root of 1.125 plus root of 2 plus root of 4.375. Should get your answer. That's all.
So is this answer an underestimate or
ये मैं बताऊँ, I'm coming. Are you all good with put it clear? Procedure is very simple. First you get the h value, then you chalk out all x naughts till the last xn, जो भी आ रहा होगा. Then corresponding y values, and then plug into the formula and then your answer. So this is basically your step 1. Get the h value. This is your step 2. Get all the x's. This is your step 3. Get all the corresponding y's, and then this is your step 4. Plug in the formula. Are you all okay here? Acha. Now, how do we tell whether the answer is an underestimate or an overestimate? Actual answer तो नहीं हमें मालूम, but by the diagram you can. Now see, if this is how you judge. Make one big trapezium from one end to the other. So basically, if I were to use one big trapezium, this is the area I would have found. Is my answer more or less than what is required? It's more because I am taking in this unbounded area also in my trapezium, which means my answer is an overestimation. Now, how do you reduce that overestimation? Your answer will always be an overestimation. How you reduce it is you take as many trapeziums as you can. The more trapezium you take, the more closer your answer will get to the actual. But it will still be slightly overestimation. Now, so a rule of thumb, if your curve is an upward bending curve, then you will get an overestimation. Okay? If it's an upward bending curve, then you will get an overestimation. Okay? If your curve is a downward bending curve, then you will get an underestimation. Writing is so bad. Let me try to write it, please. So if it's a downward bending curve, you get an underestimation. If it's an upward bending curve, you always get an overestimation. Right? And next thing that they might ask you is to find the percentage error. Now, percentage error you need to know the actual value, which means either they will give you the actual value or they will give you such a function which you can indicate. ठीक है, one of the actual value कैसे आएगा? So it's going to be actual minus estimate का mod, ताकि minus से ना कराए तो हट जाए, upon actual into 100. This will give you the percentage. actual minus estimate. Actual minus estimate. Actual minus estimate, take them all so that you remove the minus sign if there is any minus sign. Upon actual into 100 will give you the percentage error. नहीं आपके जो percentage proportion comparison होता है हमेशा with the basic or the original values होता है. It's like how you find the percentage profit, that's the amount upon the original price. Are we good? Trapezium rule दिखाओ. Trapezium rule कुछ भी नहीं. We can do one more question. बाकी आप कुछ भी नहीं trapezium rule just for the sake of practice. Acha, one more thing. In the question, guys, hear me out. This is important. In the question, he said use 4 intervals. Acha, now notice something. जब आपने 4 intervals दिए थे, how many? These are called ordinates. 1, 2, 3, 4, 5. These are called ordinates. Ordinates. O-R-D-I-N-A. That is why this is called an ordinate. That is why we say X coordinate, Y coordinate. Because they both form an ordinate, a pair of ordinates. So, if you've broken your area into 4 trapeziums, you're ending up with 5 ordinates. So, your number of ordinates will always be 1 more than the. Now he might also say this in the question. He might not say, use the trapezium rule with 4 intervals. He might say, use the trapezium rules with 5 ordinates. So if he says 5 ordinate, that doesn't mean n is 5. That means n is 4 because your number of ordinates will always be 1 more than the number of intervals. Your n is the number of intervals. So just keep this in mind. That number of ordinates. Ordinates is always equal to n plus 1, where your n is the number of intervals. ठीक है, तो किसी तरह भी बोल सकता है. So don't get confused कि यहाँ पे इसने 7 ordinates बोल दिए, that means n is 6. Then he's talking about 6 trapeziums. One question, then we are done.
I'm not. You are.
Are we having lunch at 2 o'clock?
He's lying. You said that to me. I didn't.
How's that?
Why are you bullying me?
But I heard you. Okay, last question. ग्राफ तो अपवर्ड बेंडिंग है, बट वो आपको ग्राफ देगा या he will give you something whose graph you do recognize. He won't give you something जिसका ग्राफ आपकी recognition से बाहर हो. तो जिसका ग्राफ आपकी recognition से बाहर होगा उसका ग्राफ बना हुआ दिखा देगा आपको. And that matter. Like the previous question. Why not is 1. Why not is root of 1.01.
Yes.
And y2 is root of 1.04.
Yes, yes.
1.09.
Yes. 1.16.
Yes, 1.16.
1.25.
Yeah. 0. 0.5. But connect to two decimal places. Are you good?